So problem 3 is the TC201 problem, where we have to take in two numbers, output their maximum. Okay, I think if you've been doing the TC201 problems in the PSET, this won't be too hard for you. But if you haven't done the PSET yet, this might be a little tough. I think I'll just kind of try to write mine out. I'll input 0, I get their first input, I'll store it in x. Down here I'll have x data 0. I'll get another input, 0 again. I don't need to even store it because, because it's in the accumulator right now. Actually I do need to store it because I'm going to need to output it potentially. Or maybe that's the easier way. So here's y data 0, because my plan is to take in one number, take in the other, subtract them, and then output the second number if my number's still positive, and then output the first number if it's negative. But if I subtract it, I can't just output that. So if they give me 5 and then 7, I subtract them and I get 2. I can't output 2, I have to output 7. So I could add this back, or I could just store the 7 down in y. I think that's my plan. So here I'm going to say store y. Then I'll say sub x. Right, this will give me 2 in my accumulator. I'll skip pos 0. So if it's positive, I'm going to skip this line and go to here, which means that this second number was larger. So I'll say load y, output 0, halt 0. Else here I'll say, it's not do jump, it's just jump to later. Here's later, where I load x, output 0, and halt 0. Okay. Again, if you've been doing the PSET, this should make a lot of sense. If not, it might be a little bit confusing. I highly recommend finishing this PSET before the midterm. I think it'll help a lot. I think there's also a 3B. Let's see if I can just answer these questions for you. It says, describe each of the following 16-bit sign magnitude representation of numbers. So this is where the leftmost digit represents whether it's positive or negative. If it's a 1, then your number is negative. If it's a 0, then your number is positive. And the later 15 represent the binary representation of your number. The program counter is used to indicate what step of our program we're on, or what address of RAM our next instruction is in. Here it says, the arithmetic error bit of the TC201, well, that is used to tell us if our math has gone poorly. So I think in add and sub, you say, if the number is too big or too small, then we set the AEB to be 1, otherwise it's 0. So the arithmetic error bit and skip error together, skip ERR, skip error, allow us to tell if our numbers are getting too big or too small, and maybe do something different in those cases. The fetch execute cycle, I think the basic idea of the fetch execute cycle is with these two TC201 programs, you have your program counter, you go to the address that the program counter indicates, you get that instruction, you execute that instruction, and then you increment the PC and you start again. I think that's the basic idea of the fetch execute cycle. And you only perform it, until some halt condition, or until your instruction is to halt, or until you set the run flag to be 1. The run flag to be 0. Is that when you stop? Check me on that. But one of those, right? So you fetch an instruction, execute that instruction, and you keep doing that until you change the run flag because you've hit a halt instruction. Okay. Is there anything else that I'm missing? No, that's all of 3. Now we'll move on to 4.